Okay, while everybody filters in, I just wanted to take a few moments to say thank you to our sponsors for today's class. First up is our 2021 education title sponsor, Structure Home Warranty. Tiffany Acree is our representative, and she has provided a video for me to share with you all. So just one moment and I'll load that up. Have any questions or in need of their services, again, Tiffany Acree is a representative. On all my follow-up emails and reminder emails, I CC all of the partners so that you can easily connect with them. Also, we have Kevin McLean with DuPont is another partner. He was not able to make today's class, but he is a wealth of knowledge, a great ambassador of education. We're lucky to have him on the committee and as the chair in the past. So if you have any questions, you can reach him. We also have Texas Builders Resource Group. Their contact representative is Tom Sadler with Tom Sadler and Associates. Texas Builder Resource Group is a group of associate members that have come together to help our builder members with any questions that they can assist with. And last but not least, we have Samsung Builder Services. Kristen King is their representative. They have a great product line and would love to help you out with any of the needs that you have. And with that, I'm going to ask Matt Mitchell, our 2021 Dallas Builders President, to introduce today's speaker.
All right. I think I first ran across Tony Childress, I don't know, 15 years ago or so, at the Dallas Builders Association, teaching a class on foundations, and it was outstanding. He first introduced me to a system called tella firma foundations, and it kind of blew my mind. And I started using them, and it blows everyone else's mind as well. But I've gotten to know his company, been around for a long time. I've gotten to know a bunch of the engineers over there and do a lot of business with them. And I really appreciate them being a member of the Dallas Builders Association and just being willing to come on and teach and be a part of this. So, Mr. Childress, I will turn it over to you.
Thank you. Now, I don't know how many of the people here today were part of the Foundations 1 class. If you were there, you're going to hear the very beginning all over again, but I'm assuming some people weren't here for the first class. So, oh, I got to share screen, don't I? Okay, let's do this.
Correct. The majority of the folks that were at the first class are here at the second class, but we do have a few new faces. Those that are new today, we have Foundations 1 on demand. I'll share the link by the end of the class for you.
So just to confirm, can you see my screen?
Yes, sir.
Good. So let me get over here. So what we're going to talk today is about suspended foundations. And in fact, forget about the copyright material. Nobody wants this stuff anyway. We're going to learn a little bit about codes and how they affect suspended foundation design. We'll talk about the foundation designs. And then we're also going to talk about, in fact, let me pull up my slides, some inspections and failures. I ran out of time of being able to go through a really good detailed list of inspection, but I do have at least addressing why things go wrong with suspended foundations. I always like to start off with this to remind everybody that I am an engineer. If you haven't seen it, it's worth watching again.
worried about little Gilbert. He's not like other kids.
What do you mean?
Yesterday, I left him alone for a minute and he disassembled the TV, our clock, and the stereo.
That's perfectly normal. Kids take things apart.
The part that worries me is he used the components to build a hand radio set.
Oh dear.
Is that bad?
Normally I'd want to run an EEG on him, but the machine isn't working. It's worse than I feared.
What is it?
I'm afraid your son has the knack.
The Mac?
The knack. It's a rare condition characterized by an extreme intuition about all things mechanical and electrical and utter social ineptitude.
Can he lead a normal life?
No, he'll be an engineer.
So I tell that story because I was going to school as an architect, and my mom was so proud of me for being an architect. And then when I came home and I said I changed my degree to an engineer, she said, "Why?" So, but these are my observations and my experiences as an engineer, not a builder, not a homeowner, but just the other thing I like to go over is codes. You know, people think that the codes really started having an influence on us in what they call the modern code. You know, IBC, UBC, things of that nature, but codes really started a long time ago. They started at almost 1800 before Christ. The very first code that was ever found was the Code of Hammurabi. And the Code of Hammurabi had a whole list of codes, and this is a shortened version again. I give an all day long presentation on codes, which is pretty interesting, but these are just excerpts of how the codes got here. But Hammurabi says, if a builder build a house for someone and does not construct it properly, and the house which he built fall in and kill its owner, then that builder shall be put to death. So the question becomes, why would Hammurabi have wrote that in their community's requirements? Because obviously somebody built something, someone who got killed, and they learned from those experiences. So they say, hey, we shouldn't do that anymore. Moses, when you build a new house, make a parapet around your roof so that you may not bring the guilt of bloodshed on your house if someone falls from the roof. Now, these are just lighthearted things. Wasn't lighthearted back at the time when someone fell off the roof, but it just goes back to show that when things go wrong, codes change. So I'm not going to go into the rest of these. It really is pretty cool. But when things go wrong, codes change. Codes are put into place to try to stop things from going wrong. So a lot of the things we'll be discussing and the codes are addressing things that went wrong. Now, I don't have time today, but there are so many things in the code today that have nothing to do with what's gone wrong, has to do with money. These big companies want to get their products pushed through into codes. They spend a lot of money with lobbyists. They influence that with these lobbyists, and codes change, which helps them sell more product. I'm not a big fan of that. I've been engineering stuff for well over 30 years, and I can't necessarily say I agree with all the codes, but that's just my 10 cents worth. There are really three types of foundations. There's pier and beam. Pier and beam suspended, which is we're going to talk about today, been around for a long time. There's elevated concrete, and we'll talk about all the different kinds of elevated concrete. And there's slab on ground. Now, we're not talking about slab on ground today. That was part of the Foundations 1 presentation. So let's look at these types of foundations. A pier and beam foundation. A pier and beam is the most traditional foundation system that's been in construction forever. I'm not saying it's most current today, but it's been around forever. The floor system is supported by a series of beams. They're supported on piers. It's a pier and beam. There's a pier. It can be a steel pier, concrete pier. It can be trees, believe it or not. And it's a floor system, whether it's wood, metal, concrete. The homes in the 1800s to the 1900s. So I only see so many faces, but has anyone ever heard of a bow d'arc pier? So bow d'arc piers are all over the place, but you don't see them in homes past the early 1900s. Bow d'arc piers, and I'm going to skip forward a second. Well, I'll do it in a second. Boat arc piers were really effective for the time. They're a worthless piece of tree. You can't burn it. You can't cook with it. But man, it's strong as an ox. It'll last forever. And forever was about 75 years. But after 75 years, they decay quickly. So at a boat arc pier, there's a boat arc tree. And now here you're seeing that wood piece right here is a boat arc pier. It's a wood stump that's set in the ground that holds up the pier structure. Now, what you see here is a foundation repair, okay? Because these piers are starting to fail. But these are just examples of boat arc piers. So the older, if you're a builder and you're buying a 1900 home that's a pier and beam and you want to renovate it, you had better inspect the piers. If they're the original boat arc piers, they're worthless because as soon as you touch them, they fall apart. That's what a boat arc pier is. So more currently now, an upscale version of a suspended slab. These are expensive. This is a concrete suspended slab. So these are concrete beams on concrete piers. They'll have metal deck, sometimes where the garage goes. They'll actually have wood trusses where the floor goes. Now, these can be wood beams, not concrete. These can be helical piers. It's any kind of pier and beam, and everything underneath this is called a crawl space. Here's what a wood framed floor would look like for a pier and beam, where everything else below there is a crawl space. Here I am underneath the crawl space. You can see I've got room there. You get your plumbing runs below ground and is suspended. The plumbing doesn't sit on the ground. It's tied by hooks that come, it's tied by hooks that come up to the bottom of the structure. And then this one is nice, it's gravel. You'll see there's a felt membrane down here. A lot of times all you'll have is dirt. So it depends on how you construct it and whether you're worried about moisture coming through. There was a lot of worry about moisture being trapped underneath these foundations. So a lot of builders were putting a vapor barrier and putting gravel to hold that vapor barrier down to make sure that moisture in the ground didn't permeate through into this crawl space, which then causes, decay. Typical details, not a lot to go into, but again, the whole thing is even my beams have a void box, so I have a void space to make sure that the soils don't move on my structure. What's the advantages of a pier and beam? I can design it to carry anything. If you have a fireplace, I can design a steel beam or whatever I want. So I can make this handle any kind of load you want it to handle. It's not going to move from soil. If the soils swell, we don't care. This thing is suspended above the soils. Now, you want to make sure that your void underneath your beams is at least 2 times what's called your PVR, the potential vertical rise. So soils can move 6 inches from dry to wet, you want a 12-inch void. If it's 8 inches, you want a 16-inch void. And it can be used anywhere. You could use it on rock, on clay, on sand, on sloping sites. Really the soil characteristics will affect the size of pier, but I can use this anywhere I want. Disadvantages. Number one, it is expensive. It is very expensive. It is the most expensive foundation system out there. 2, takes longer to construct. That's why it's also expensive. And 3, you have to worry about moisture entrapment under the crawl space. We'll show you details later, but your crawl space is below the ground. Where does water want to go? To the lowest spot. Water always wants to collect underneath the crawl space. You get water underneath there. If it gets trapped, you get mold. If you get mold and you haven't sealed up the bottom of your pier or your beams properly, you could get mold into the house. So drainage under it, keeping the water from getting in, all has to be considered. Now, what codes affect pier and beam? So first of all, if you're going to do a pier and beam, there are 5 things the code specifically addresses: ventilation, access to the crawl space, finished grade, flood resistance, and ground clearance. Now, access. We're going to talk about void box slabs and tella firma, but a void box slab and tella firma both have voids underneath their structure, but it's not a crawl space. There's no access to it. For it to be a crawl space, there has to be a certain height. So these requirements that I'm giving you only apply to pier and beam. They don't apply to suspended slabs, such as void box slabs or tella firma. So I'm not going to read all this. This is for the engineer. It says for every so many square feet of area under the ground, I have to provide vents for it to breathe. And you'll have this in a slide, but that's what these are. They're holes in the side of the beams that allow air to ventilate in and out. You need that air to ventilate because if you don't, all the moisture is going to get trapped, will get into the wood and rot it. Now, these vents can also be problematic because what happens during the wintertime? What happens during the wintertime when all that cold air comes in? So there's covers that you can put on these vents. You can put a cover on there to stop the cold air from coming in during the wintertime. But if you don't take them off, then it doesn't allow the air to breathe. So they also have electric vents that you can open and close. A lot of people will use a controlled damper in there that if the moisture gets to a certain level, it will trigger a damper which will blow air out to these vents. But ventilation is crucial and the number of vents is crucial. The biggest mistake builders make is not installing enough vents in their structure. Crawl space. A crawl space, and again, I'm not going to read all this, there's a certain height limitation that you have to have. I'd rather show you, I'm sorry, this is access. I need at least an 18 by 24 opening to get to the crawl space. So there's two ways of doing crawl spaces. One, you have a door to the outside. Well, those are really good, but then you have to have a lock on it because how many people you want being able to open up and go underneath your house and get in? So the most common is an in-floor access where you have a piece of plywood that's covering up a hole with carpet on it or what have you. You pull up that carpet and that piece of plywood and you crawl right down into your access space. So those are the type of access, but the code requires at least 18 by 24. Any questions so far? Okay. Then we have crawl space access. So I have to have enough access under that structure to install equipment. It gives me all kinds of rules and regulations of what it has to be. I think I've given you a drawing here in a second. That's a crawl space. It's actually current construction. You can get underneath there and crawl really easy. The older homes, this could be as close to 12 inches or 8 inches to the ground, and you can't crawl. But the current code requires a distance. Sorry, you'll see it in a second. I've added a detail that it is from here to there, I believe is 24 inches. It's 32 inches to the floor and 24 inches to the beams is your crawl space requirement now. Finished grade. Your finished grade, this is your top grade, so not your rough grade, but your finished grade should be 6 to 8 inches below your sill plate. The sill plate, if it's wood, needs to have 8 inches so the soil doesn't wick up and put moisture into your sill plate. Now, flood resistance. Again, I've only got so many faces, but has anybody ever had to deal with FEMA and flood resistance when it comes to dealing with their homes? Oh, I see one hand up. Fantastic. I got involved in this. Oh, wow. It's a long time ago where a flood hit Lancaster and all these homes under FEMA had to get money for all the damage. And then they said, if you raise the home, put it on CMU blocks and put holes in the blocks, we'll give you insurance again. Because the house can be in a floodplain, but the foundation has to be above the floodplain. But you have to allow water to flow under the house. Isn't that wild? And it is now required that if you're a pier and beam and there's a potential for a flood, to meet FEMA, you have to give it access. So what it is like vents, like a pier and beam vent, but they're bigger. And the idea is as the water rises, instead of the water pressure building up on the house, the water will actually go into one of these holes. It'll run under the foundation and out the other side. It's called equilibrium. If there's water on both sides, there's very little pressure. And here you can see water pouring out from one of the vents. And you can see this is a pop-off. This is a vent that during a flood, it blows off. Now, that's not a real condition. That's just a test showing the vent blowing off. But if you have a home that's in a floodplain, you can actually hire a house mover and raise the house up. You can build it on CMU blocks, put holes in the CMU blocks. Now there's a calculation of how to do that to make it meet code. Ground clearance. You got to make sure that we don't have a termite problem. So we have to keep the ground from termites. So again, here is the I was wrong. It's 18 inches to the bottom of the floor and 12 inches minimum from the bottom of a girder. But your sole plate here, no closer than 6 inches, and the top of the floor is no closer than 12 inches from the ground. For your exterior walls, I just showed that. For your sheathing can run down further, but it has to stop 6 to 8 inches from the ground. You can't run your sheathing, now this is taken from hardy plank. Even the hardy plank has to be 8 inches from your final grade surface. A lot of builders make the mistake and they put their grade or their trim carpenter will put their hardy bore up and they come back with the final grade, add 6 inches of final grade, and all of a sudden you get rot and deterioration of your hardy plank or your siding. All right, that's the Reader's Digest version of pier and beams. Now we're going to talk about suspended foundations. Suspended foundations are similar to pier and beams, that they're suspended above the ground to avoid foundation movement. They're most commonly a concrete mat foundation. A concrete mat means just a flat piece of concrete, sometimes with beams. And you have to have piers. To be suspended, you have to have piers. It could be concrete or steel. And the most common method historically has been what they call void boxes. And then, so a void box is a wax carton form. It is actually designed to go in the beams. It stops the concrete from touching the dirt. Now, where there's a pier, there is no void box because you have to have the pier touch the concrete. Now, that void box is designed to hold up the weight of concrete for about 7 days. After that, the wax gives out, the cardboard rots, and it creates a void. Problems with this sometimes is people make their own cardboard forms and make it out of plywood, and plywood doesn't rot. So when the soil moves, the foundation moves. And people will say a plywood box cannot pick up a foundation. Go talk to Mansfield High School. Their entire high school heaved up off the ground because the void boxes never, ever rotted because they were custom void boxes made so strong, they weren't going to fall apart. So that on the left is a void box going in. On the right is a suspended slab with metal grating. So just different types of suspended slabs. This is kind of what a foundation design looks like. This is a waffle slab. Your dots are your piers. These little bridge looking things are your void boxes. So again, there's no load that should hit the foundation or the void box.
I'm on a class. What do you got?
Oh, sorry, someone's taking a call. That's fine. Again, details of it. Now, I'll let this video. I'm going to pause this for 1 second. Well, I'll back it up and do it over again. Sure Void gave me this video. I'm not advertising Sure Void. I'm not advertising anybody. But since they let me use this video, Sure Void makes void forms. And this is a short video on how those things go together. There is no sound. So there's your, of course, this is on the perfect world. So there's your foundation. And these are void forms that go around your piers to make sure your piers are nice and flush. Then there's your void boxes that go in your beams. So what they're trying to do is as the soil tries to move, those void boxes crush and rot. But if you don't have a void box there, it's going to crack your structure. You see the concrete cracking. Uh-oh, watch this. Picture's going to fall. Wait for it. Come on, that's cute. So you have to have void boxes under the structure as well. So then they come back with void boxes on top of your pads. Now you come in with your poly. They put a protection board. Nobody does this. They should. But you put a protection board down. The protection board is as you're walking on it, it stops the boxes from crushing. Again, this is now an isometric version of the same thing. Again, the seams are supposed to be covered up. I can tell you that never gets done in residential. That's one of the defects is concrete will go in between those seams and cause problems. But again, I'm showing you in a hypothetical perfect world. Now I do love this portion. So I stopped it. We, in the foundation 1 class, we talked about the poly being cut, that we don't want poly in the bottom of beams. Then the code requires the poly to be everywhere, but as engineers, we say, no, don't do it. It should be on the top of the slab and on the beams. This is a good video of why we recommend cutting the poly and not having poly at the bottom of the beams. Maybe it'll show it, maybe it won't, I can't remember. That's what really happens. You get a sag in the poly. You pour the concrete. You end up with the airspeed, the void. So that's why we always recommend cutting the poly like this. So that way, there's the poly, you cut it, nail it to the side so it doesn't get in the way. And now you don't get those air pockets between your poly and your void forms. So again, you put your protection board down, then you got to bring in your reinforcing. So whether it's a rebar slab or a post-tension slab, so, you know, you put your reinforcing in it. Of course, your chairs to hold up everything. And one was example of post-tension, one was example of rebar. Wire mesh, not really used around here. You pour your concrete. And now when the soils move, hopefully your house doesn't move. So I hope this really gives you a good understanding of a void box slab. So now your house stays together and the sun comes out and the birds go flying and Everybody's happy. Got to wait for the bird. Then it comes out. And there goes the birds. Okay. So, all right. So that is how a suspended void box slab works. There's another suspended system. It is a system that I patented over 15 years ago. But this is not a sales speech. It's oh, wait a minute. You got to finish its advantages. It's more affordable than a pier and beam. It is highly resistant to soil movements. My void boxes can be 12 inches, 8 inches. You can design your void boxes to whatever height you need. And it's the least amount of maintenance between, we don't worry about water getting underneath the foundation, because if it does, it's a concrete foundation. That's no different than a slab on ground. Disadvantages, still expensive. It's cheaper than a pier and beam, but it's between $4 and $6 minimum a square foot more expensive than a slab on ground. So it is still very expensive. They're hard to install. If you've ever done a void box slab and you have to walk on a void box, you're walking on something that crinkles and cracks while you're working on it. It wobbles. And these guys are working on it all day long. And it's not very common. Not every concrete guy knows how to install it. And if you don't install it perfectly, concrete will get between the voids and you end up with localized heaves. That's the number one failure in void boxes, is concrete getting around the void box, making contact with the ground heaves, and then the foundation heaves. All right, this is called a post-lift foundation system. Post-lift means you pour it on the ground and then you pick it up. It's a tella firma system. This idea is not the first time that buildings were raised. So going back to 1866, in Chicago, the Briggs House, after they built this 3-story building, the river was growing bigger and bigger due to the amount of people that were coming, and the water was rising at a point where these buildings were in trouble. And an engineer designed a way to put jacks underneath all the beams and raise the entire hotel. 1866. As a matter of fact, they did the whole city block in 1860 by raising it. So this is nothing new. It's just different. So in the world of commercial construction, there's this design called two-way post-tension concrete. What you have is a slab of concrete, just flat concrete. There's no beams. It's just a chunk of concrete. It's post-tensioned, and it sits on columns. You'll see this in every parking garage you drive into. You'll see it. Now that you see this, you'll drive around, look at new construction and go, oh my God. Now, if it has beams in it, it's not a post-tension waffle slab. It's a waffle slab. It's not a post-tension flat slab. This is an example of a post-tension flat slab. So we came up with this and said, look, if I can do that and carry all this load, why can't I use it at the ground floor and carry the foundation? So we came up with what used to be called slab tech, for slab technology. And eventually I had to run Childress. I couldn't run 2 companies. So I partnered with some people and changed the name, and now they run it. But it's got the strength of a pier and beam, forms like a suspended slab, but it's built like a slab on grade. So here's how it works. Oops, I'm sorry. So here's a little video. You have your form board set up. You put your piers in. They can be concrete piers, steel piers, helical piers, doesn't matter. And then you pour the piers and you put a mechanism in the pier. It's called a lifting mechanism. And then you have to come in and put your plumbing in. Oh, there's no beams, by the way. So when your plumbing goes in, you don't have to worry about digging through all those beams. You don't collapse on the beams. Your plumbing is easier to install because you're doing it right on flat concrete, on flat ground. Then you dig these capitals. Capitals are these little chunks of concrete that go on the bottom, and your post-tension cables go in. And the cables go in differently than a slab on ground. They're actually profiled. They're very systematic. There's a pattern to it, but they go in. You pour the concrete, you stress the cables, and after your cables are stressed, They literally by hand raise the slab out of the ground. Wait to catch up. Now, you have plumbing that's in the ground, and the code, and I should have added this to my slides. I apologize, I didn't. The code for any foundation, slab on ground, suspended slabs, your PVC cannot be in contact with the concrete at time of pour. Your copper cannot be in contact with concrete. The copper will have a thin sleeve around it, and the PVC has to have some type of protection around it to where the concrete as it's curing doesn't bond to the concrete. A lot of times in slab on ground, you'll see people using cardboard, carpet, anything. But so here, what they do is as the slab is being raised, there's a plastic sleeve under the plumbing connection. So as it goes up, it just goes up. The plumbing just stays in the ground and it goes up. There is an option to suspend the plumbing with it. So you can strap the plumbing to the concrete when it's poured. So when you pick it up, the plumbing goes up with it. You can reach out to Firma. They have all kinds of videos on that, but that's not part of today's discussion. When you're, well, I'm gonna go back a little bit. Oh, I went too far back. Come on. Come on, see if I can get this video start again and see if I can, no, I can't. When you suspend it, you get a void. And so here is a time lapse of a foundation coming out of the ground. So it's the same thing as that commercial slab. It can carry a tremendous amount of weight, but now I've got this void under the structure. Some of them have a drop down beam. So some of them you'll see there's a beam here where you can't see the void. So here you see the void. I've got other examples where there is no void. Now, what you do here is you'll end up putting a void, a soil retainer here and backfill the soils. Or if you have a drop down beam, you don't have to do anything. This home was a very unique home. The outside edges of it goes over a creek, and they wanted the whole thing just to cantilever out like it was floating in air. So this is a home that was completely suspended, and they wanted to look completely suspended, and that's what it was. So there's no void boxes. Now, we do recommend a minimum amount of void boxes at plumbing, but there are no void boxes. What are one of the bad things about void boxes? Void boxes, you put them in the ground, then you put your rebar in, you get your foundation finished, and then it rains. It rains for a weekend. Those void boxes are ruined. You got to take out all the reinforcement, take out the void boxes. Now, if you anticipate you're going to have rain, you can actually pay the manufacturer to put a heavier coating. It's an exposure factor. How long will it be exposed? And they'll put a thicker coating of wax, and they'll use a thicker a member of the cardboard. So if it rains once, it'll be fine. Now you pay more money for that, but now it's going to take longer for that void box to decay, and it can become problematic. So with this system, there's no void boxes. That's neither here nor there. This is a truly engineered, so a slab on ground is a hypothetical approach. It's hypothetical because, by the way, I am the chair of the Post-Tension Institute Slab on Ground PTI committee. I'm on the board of the Post-Tension Institute. So what I'm telling you is a theory. Slab on ground is the best method approach to designing slabs on ground, but soils are so unpredictable that it's a hypothetical. It is not true, what they call empirical engineering. There's engineering to it, but it's based upon a bunch of guesses. And that's just the way it is. It works. It's proved itself to work through history. This is all empirical. When you have an elevated concrete slab, you know exactly how it's going to perform if it's built right. It's like any commercial, if you're in a commercial building right now, you know, that thing's not moving. It's known. It's got century more of history. So it's modeled as it is truly suspended in the middle of the air because there's no ground touching it. Your columns are your piers. So that's actually a model from the program of a tella firma slab. So again, here's one being elevated that's got a beam. Just the other one that I showed was being elevated that didn't have a dropped beam. All right, so here's your pier capitals. Your cables go in, there's rebar, all this, the entire time, the ground is nothing but a temporary shoring. So when you build these buildings up in the air, they use wood and plywood to build this exact same system. So your cables, as you notice, are profiled. They go up and down and up and down. That gives you the overall strength, where post-tension cables in a slab on ground run relatively straight. And then basements, you can do basements with them. We've done basements with all different kinds of methods. You raise the basement first, then you raise the upper levels second, and you raise them to the same level. If you have a big home, you're building a monster home, and you have to have steel columns. Now, a suspended slab that we're showing can handle 3 stories of load. You know, no big deal. But let's say you've got a 2-story home, but you've got a great room that's 50 by 50, and you have a steel column that's carrying 50,000 pounds. Well, that's not smart to put 50,000 pounds on a suspended slab. So what you do is you put yourself a pier, and that pier is what your column's going to sit on. Here's your slab on the ground. After you have your steel erected, you raise your slab. There's a small void box right there. Then you pour that concrete. So your superstructure, I've got jails sitting on this thing. We got schools sitting on this thing, churches that have these big, massive columns. Those big, massive columns do not sit on the tella firma slab. They sit on a pier. Now, if I've got typical wood columns or steel columns that's carrying 2,000, 3,000, 4,000 pounds, you can put it on it all day long. So we're talking about superstructure loads. That's the example of, this is a big custom home off of Midway. So that's just an example of a home that had a steel column with a lot of loads. If you got a large slab, you've got a slab that's 300 feet, for some reason, you cannot put cables more than 200 feet's a good number, 225 in a post-tension slab. 2 reasons is, one, a human being can't carry a cable that heavy. You'd have to use a forklift. You can't drive forklifts over the slab. Second is how much you can elongate a cable from each end. So if you've got a large slab and you've got to have a leave out, your leave out is done just like a normal slab on ground leave out, where there's a jacking gap right here, usually 3 feet, with dowels sticking out of it. You raise both slabs, put a small void box there, and pour the rest in later. Again, very rarely seen in houses, but when you're doing apartment complexes, very common. A thing on helical piles. Helical piles are becoming more and more common in residential construction. They're rarely used in residential except for foundation repair. And the reason is they're expensive. Helical piers are a Cadillac. They are phenomenal. They're expensive. But technology over time has changed, and with people having belt piers or collapsible piers or really deep piers, we have been using more and more helical piers just because they're cheaper. They're not cheaper than a 15-foot, 12-inch diameter straight shaft pier, but they're cheaper than a belt pier, or they're cheaper than really deep piers. And helical piers are just drilled into the ground. They use the compression of the soil to lock them in. You have to get past the active zone. These piers come in different sizes, different depths, and different size helicals. The code tells you that, well, these are what the capacity of these helicals from the manufacturer are. You know, I've got a 2-inch square shaft pier that can handle 160,000 pounds. The allowable is 80. The reason why the allowable is 80 is the code says, and do I have it in here? Yep, maybe I do, maybe I don't. The code requires you have a safety factor of 2. on your helical piers. So if it can handle 160, I'm allowed to only use 80. So these are approved by code, but the loads that we use come from the manufacturer divided by 2. So before I go into what goes wrong, any questions? I don't know if I can see my chat thing. Let's see if I can find it. Let me minimize this. But no, I don't see any questions. For some reason, Sheena, I don't see my chat box.
I'll drop in a message.
Let me go to.
Tony, I have a question
Sure.
on pier and beam foundations. Don't the beams still bear on the soil?
Absolutely not. That is not a pier and beam system. Now, if the reason is your beams, a pier and beam system, you have to have a void underneath your beam. Now, can you design a suspended slab with a beam on the ground? You can, but you understand when that soil moves, that beam is going to move.
Right.
Right. Now, the problem with doing that is all your load transfers to the beams. The beams have to be wide enough to carry the bearing. So when a slab on ground, your beam and your slab carry the load. In a pier and beam, your beams carry all the load. So your loads are much bigger. So your footers have to be wider in the soil. The wider the footer, the more soil pressure you're going to get. So now your question really should be, don't some people do it that way? Yes, some people do it that way, but it's not going to perform like a pier and beam. It's going to perform like a deepened beam in soil, and you'll stop getting movement in your slab, but your foundation, your beams are going to move. One of the things that's out there, and I'm not putting it down, is these waffle mats, where they put the waffle mat down and it creates a void under the pad, but the beams sit on the ground. I can show you how many cases of a foundation built that way. I'm an expert witness on from foundation movement, not saying with the waffle mat system, but with beams that are in the ground. Because your beams, when your soil moves, the beam has to go with it. Does that make sense, Matt?
Yes. Yes.
So no, a true pier and beam has to be suspended. Also, piers on a slab on ground, we spoke last time, piers are never, ever, 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 ever tied to the foundation. Never. I don't care if your soil has only got 1-inch PBR. You never let a pier structurally attach to the foundation. That foundation is going to heave over time, wet season, and you got to allow it to move. On a pier and beam, you always, well, no, you should tie it to it, okay? Do you have to? No, you don't have to, and here's why. If you're doing a concrete beam, the weight of the concrete is heavy enough on the piers that the friction force will handle all the lateral load. If you have a light foundation system, then you need to make sure it's secured, because under the wind, what stops the building from shifting off the piers? So you have to worry about whether you secure it or not. We always say you want to prove it secured. So, oh, there's my chat box. I finally found it. Thank you. Again, questions are certainly great by voice or by chat if they want. All right, so this is the part that I'm going to let you down a little bit because I don't have a lot of photographs to show, but let's talk about what goes wrong. Oh, I got to go back over here. So obviously that one wasn't anchored very well. Anybody know that story? That's a real story in Taiwan. But yeah, the piers weren't deep enough and that thing flopped over.
I looked it up after your first class. It's incredible.
Incredible story. It's a great article on it. So the loads on the slab. So if I've got a pier and beam, the code tells me what I have to design for. They tell me what live loads, what dead loads. You hire a flooring company, a framing company, they're going to design the subfloor. Now, here's what's bad about the code. The code tells you design for 10 pounds of dead load and say 40 pounds of live load. So if I've got 40 pounds of live load and I've got a piece of furniture that's, I'll just say it's 5 by 5, so it's 25 square feet, and it weighs, I'm allowed 40 pounds. So that's, what's that? 25 times 40 is 1,000 pounds, I think. 25, that's 1,000 pounds. Shows you how good of an engineer I am. I had to use my calculator. So it's designed for 1,000 pounds over a 5 foot by 5 foot area. But that homeowner just bought himself a marble, whatever you want to call it. The last one I saw was a solid marble pool table, weighed 5,000 pounds. And then they sue the builder because he didn't design his home to handle his 5,000 pound pool table, especially on a pier and beam. If it's a slab, it doesn't really matter. But a pier and beam, you get over deflection. So you really got to make sure that what you're designing a pier and beam for by code meets the homeowner's expectations. Are there anything that they want? Do they want a concrete topping on their floor? If they want a concrete topping on their floor, you got to design your framing for it. Are they custom ordering granite bathtubs? I have seen a solid granite bathtub in a pier and beam that we designed. We got sued over it. We got let out because no one knew the homeowner was going to order a custom-made solid granite bathtub, and we met code. But the builder still got in trouble because the builder knew or was told. But so again, what goes wrong is the loads actually applied exceed code. Remember, the code is the minimum requirement. That doesn't mean the maximum load's going to be there. So another problem that occurs is with these void box slabs is, masonry fireplaces. You got a masonry fireplace. You designed it as a metal insert. And then they decide, well, we'll still want a metal insert, but can we put brick around it? It won't be a brick fireplace, but so you add more weight. Or they get into the second floor construction, and then they decide they want to add a lightweight concrete. Even worse, you get to the framing stage, and they say, we want to upgrade to clay tile. You upgrade to clay tile, which is immensely more, not only expensive, but weighs a lot more. Now you start over deflecting your walls, or you're loading your walls, which is supported by your beams. So you're having a load-bearing wall and knowing which is your load-bearing walls are critical. Because if you have walls on the first floor that aren't load-bearing and they're not sitting over a joist or a beam, and then you decide to load to it, then you get deflections. So this is not the right deflection chart. I didn't have time. So wood is allowed to deflect. A wood floor system can deflect L over 480. Again, I threw this in there to remind myself that the foundation won't move. It doesn't mean the homeowner's not going to complain that they got their master bedroom furniture in there, they got their pool table, they've got all their stuff in there, and they can feel a depression. Wood, just like a second floor, will deflect. So it's like living on the second floor. Oops, I missed one, drainage. So I'm going to go way back. I'm sorry, I really thought I had it in there. But I don't always get time to finish these presentations. What am I getting paid for this? Oh, nothing. Okay, so no, my point
Endless gratitude is your
I know
payment.
my point is that I try to do a good job, but sometimes I create new things. And so here is a pier and beam, and here's your ground level. It is below your outside surface. Where's the water going to want to go? It's going to want to go here. It is very rare that you don't walk into a pier and beam home that's 10 years old and you can't tell by smell it's a pier and beam. But water's going to collect underneath here. Now, there are multiple ways of dealing with it. One, just slope the soils in the bottom and put a drain system in. 2, you put a vapor retarder on the bottom. You put a vapor retarder on the top. You put gravel. There's all kinds of ways, but you have to worry about moisture underneath this area. Some people will build pits for water to get into. They'll put a sump pump. So when the water collects, it just pumps it out. What happens in a great storm? During a great storm, the power goes out. When the power goes out, the sump pump doesn't work. When the sump pump doesn't work, water builds up. You know, so anyway, so that is my overall 60-minute presentation. The rest is questions.
Looks like Matt's dropped a question in the chat box.
Oh, okay. At what PVR is a point that you recommend upgrading to a suspended slab from slab on ground on pier? Okay, so the PTI, the Post-Tension Institute, has published documents that says you should never build a slab on ground on soils that have 5 inches or more PVR. Again, PVR is potential vertical rise. But most cities and most geotechs won't give you design values for anything over 4.5 inches. Now, be careful. I say this all the time. 4.5 inches is the worst soil that you can build a house on. Okay, but you can. And if you have soil that's a 6-inch PVR, people spend money, water injection, chemical injection, all kinds of stuff to go from 6 inches to 4.5 inches. Now, try to explain to your homeowner, I'm building a house on the worst piece of soil you can build on. I've designed a foundation to be on that soil, and we're really, really hoping it's going to work. Now, that's why I make a living. I make a living off of designing foundations off of soil. My point is, you really want it to be less than 4.5 inches. If you got a PVR of 3 inches, man, I'm not worried. That doesn't mean your homeowner's not going to be happy with it. But once you get to 4.5 inches, you're at 4.6, you're in trouble, right? So at 4.5 inches is the cutoff. Some builders, anything over 3 inches, they go suspended. Those are more the custom builders. I do have some production builders that I can't go into it why, but anything over 3 inches, they'll do suspended. And the reason is they own the homes. They carry the notes. They don't own them, they carry the notes. And if the homeowner didn't take care of the home, they got to take them back over. So they want to make sure the foundation's not going to move. So again, the first question is about that. Let's see. Okay, the 2021 IRC, this came up the last time. The 2021 IRC isn't different. It's the same as the 2018. It's the same, the codes really didn't change. It's just the wording has changed slightly. That we are in what we consider to be a termite infested area. And if you're susceptible to termite infestation, you are not required to meet that. I don't know any city that's going to enforce the energy code on foundations because your concrete is still in the ground, you know? So I don't believe, now, if you want to do it, I do jobs in Colorado. We do the insulation boards on the sides and we do insulation boards on the bottom. But I don't believe that the 2018 or the 2021 code, as far as energy code, is going to apply because Texas and the region that we're in is more controlled by termite than by frost heave. Now, by the way, our frost heave in Dallas is 0. We have 0 frost heave in Dallas. But the code currently says that if you have 0 frost heave, you have to design for a minimum of a 12-inch embedment of the beam to avoid frost heave. That's one of the codes I don't agree with because as of 1996 or before the 2000 International Building Code came out, it was 6 inches because they said if we don't have frost heave, we ought to be at least 6 inches into the ground just to be safe. Well, when the International Building Code became the International Building Code, They took Uniform Building Code, the UBC, the Southern Building Code, also called the Standard Building Code, BOCA. They took all the building code people, they got together and they voted on the most important things to put in the code. California has a big shear wall issue. So they really wanted to keep the shear walls in place. That's why our shear walls went crazy in the International Building Code. Colorado has big frost heaves, and they felt like 12 inches was the minimum. So one thing they voted on was changing the 6 inches to 12 inches so everybody would agree. But the people down south said 6 inches. So the 12 inches was just a bunch of good people voting on a number. It doesn't mean the 6 inches was wrong. It's just now 12 inches. Let's see. If a homeowner has allowed water along the foundation for several years but has no noticeable damage, do you just remedy the situation by ensuring adequate drainage? Okay. So if it's not broke, don't fix it. So if you're the builder and you had good foundation drainage and you happen to go back and you see he's got bad drainage and there's no problem, I'm okay with you saying, hey, this isn't smart, you should fix it. But if you go to a home that's 4 years old, it's got no cracking, no movement, it's got bad drainage. If you fix the drainage, guess what's going to happen? Foundation's going to move. If that foundation was always having bad drainage and when it was built, it had bad drainage, that soil is used to that condition. Now, if it dries up, it can move, but you can't fix it without warning them it can move. So here's a good example. You build a home, homeowner buys it, they're in it for 3 years, and they put it on the market. They move out, the home is unlived in for a year, not in our market, right? But in a market where, and no one's watering it. No one's watering it. It has a little bit of foundation movement to it. The homeowner goes and patches up the cracks to try to sell the home. The homeowner buys it. What's the first thing he does? He turns on the watering. He starts watering and plants new flowers, adds new landscaping, and the foundation moves, starts to crack because they changed the way the soils were used to feeling things. It is the same as if you have a tree next to a foundation. You got a tree next to a foundation, and someone says, ooh, I better get rid of that tree before it causes a problem. You get rid of the tree, and lo and behold, your foundation heaves up. Why? That tree was sucking moisture out of the ground since it was born. That soil was used to it. Now, once you take that tree out, all that moisture that used to be there has nowhere to go. It heaves the soil because now it stays in the soil. Now, if the tree roots are starting to cause problem, you build a tree barrier, a root barrier, But drainage, I always say about drainage, you can have bad drainage and you can have good drainage and you'll have a problem. You can't have horrific drainage, okay? So somebody doesn't water perfectly, you'll be fine. It's the stupid stuff that goes on. It's the stuff where, a homeowner only waters the front of the house every day because they got flowers. They don't water the other 3 sides because they don't want to waste the water. And it's the middle of the summer, 3 sides of the house are baking dry and dying, but that front yard looks beautiful. But they got cracks in the front of their house. So one day, Sheena, if we want to do just on foundation drainage and things like that, we can do a class on that. But that's, to me, people overthink it. They overcomplicate it. It's not that complicated. Isn't it true that watering dry conditions is a key to a slab foundation? Do you recommend soaker hoses around the foundation to solve this? Okay, so what the question that Mark Den asked is a very good but dangerous question. Does anybody believe in even watering around their foundation? The answer should be, heck no. You should never evenly water around the foundation. Does everybody agree on even moisture content around your foundation? Everybody should say absolutely. You want even moisture content around your foundation. You want your soils to feel the same, but 2 sides of your house will not get as much sunlight as two sides of your house. If you water evenly, one side's going to get so much water it can't handle it. The other side's, so you want to have even moisture content. How do you do that? You adjust your watering system based upon a timing, based upon what I call the finger test. If you've been here before, you get a brand new home, you walk around the home and you walk in the front and you put your finger in the ground a couple places. If it's damp or moist, or even if the dirt particles stick to your finger, don't water it. If you walk to the other side and you can touch it and rub on it and it's dry, water it for 3 minutes, no more than 3 minutes. Once clay has 3 minutes for the watering, it dams up anyway. If you do this for a couple of weeks, you will learn, wow, my front yard needs to be watered 3 times a week for 3 minutes. My backyard gets it. Oh, my left yard, I only have to water it once every 2 weeks. You see all this dead dirt next to a house because they can't get grass to grow. It's not because of no sunlight. It's because they water it and it suffocates. Grass will grow in shade if you don't overwater it. So soaker hoses, we never recommend a soaker hose except on the sunny side of your house from May into August. You put it on where the sun bakes on your house all day long, not in the shade. I hope I'm not stepping on people's toes, but I'll go out there and I'll see a soaker hose laying out by dirt because all the grass is dying and they're watering dirt, which the dirt's already wet in the first place. But you put the soaker hoses 12 inches away from your foundation and you barely turn it on. You don't want it, you don't want to walk over there and the grass be wet. You want it to barely drip out so slowly that the top soil is just barely wet. Okay, you're not watering the grass. You're making sure the top layer of the soil doesn't get dry enough to suck out the moisture from the ground. Does that make sense? You know, that way at nighttime when the sun isn't baking on it, you're not adding a lot of water. So you just barely let it drip. Can we get a soaker hose exception? Yes. No, I have written letters to cities to absolutely not use soaker hoses. And some cities want underground hoses. We will not allow it. Our foundation designs, we won't allow it. We are trying to design a foundation to let water go away, and then you're gonna put a hose in the ground and add water to it? You know, so we are working with cities that, you know, you should not have a sprinkler zone that goes to a underground. On this home that I worked with, we had to write a letter to disconnect the soaker hose underground from the sprinkler system that the city required. And we had to explain why. Because it was in a shaded area and that part was heaving up, all due to the soaker hose. Now, if you're going to do that, put it on a different zone and turn that zone off. If you're going to say, okay, the city's going to require it, do it. Put it on a separate zone and turn it off. But that's going to go away. That was, if anybody has a concern with the city with that, reach out to me. What is the tolerance on movement for slab on ground foundations? Okay, that was in the first class, but your published criteria is the length divided by 360. So how much movement is allowed is the length over 360. That's a lot of movement. That doesn't mean that it's not going to start cracking at L over 480 or L over 600. But the tolerance of movement has to do with the length. And the problem is if you don't have a post-pour survey to know what the shape of your foundation was, how do you know how much moved compared to how much concrete was poured out of tolerance? All right, do we need to be concerned about drainage during construction when the lot is not properly graded? Yes. Is it done? No. If you aren't going to do drainage at time of construction, I'm okay with it, but you need to do a post-pour. So before you close the home, you get an elevation survey to show what condition that home is. Those soils will be moving. As the soil moves, your foundation, I don't know if anybody can see me, not probably they can or cannot, but your foundation is going to move. So if you, before you close the home, you got your grades in, you got your soil in, you've got your sprinklers in, and you show the home is 2.5 inches out of level, perfectly fine. Your tilt's probably going to be way under that. So now you have a documentation of where your foundation is, because you can't control that foundation movement up until that point. If you're trying to build a really flat slab, well, then you got to really worry about drainage and watering from day one. That's just not realistic. But yes, there's no load on the slab. The soils have no drainage. What you want is a whole slab to move together, if it will. But it's not a major concern, but it can cause problems. Foundation pour to final grade could be 2 to 3 months, so we're having so much rain. That's correct. So again, I think that you should hold your grading contractor responsible, not to meet code, but to have some positive drainage. First of all, how much fun is it to go and inspect a home, or your homeowners to go to a home and there's a moat around it and there's mud all throughout the house. There's mud on the framing because everybody working on it's got mud on their boots. You know, so give them some positive drainage to allow that water to flow away. That's my opinion. If you missed Foundations 1, Simple Solutions, you click the video. Oh, that's from Sheena. Yeah, so there's the I guess y'all recorded it, so you can watch that one. A lot of the things that are being asked are discussed in very much detail in the Foundations 1 seminar. But any other questions? I know I go fast, but I try to get everything in the time frame. I also know everybody's time is valuable.
I think you've answered everybody's questions. You once again knocked it out of the park. I really appreciate the way that you put it in terms of common sense and understanding. So thank you very much for helping us out today.
No,
Thank
any
you, Tony.
questions?
Outstanding.
Thank you. And thank you for letting me be here. And everybody enjoy your week.
Thank you, everyone.
Thank you.
Bye-bye.
It was awesome. Mhm.
Thank
Bye.
you.